When you want to do the math behind a physical process, like a chemical reaction or a collision, you can count on some things being the same before and after that process. We call these dependable things conserved quantities. That's what's up next on PS 100. Mass number, charge, and energy are all conserved quantities. In this episode, we'll just talk about momentum. Momentum is calculated using an object's mass and velocity. And there are two types of momentum, linear momentum and angular momentum. If you've ever played pool, you've probably unconsciously used the principle of linear momentum to your advantage, especially if you've ever faced a setup like this. The idea is to hit both of these balls into their pockets with one shot. To do that, you've got to transfer the cue ball's momentum into both of the balls. But because momentum is a conserved quantity, the momentum of the cue ball is going to be split between the two balls, and each will only have about half the momentum of the cue ball. So, at the point of impact, this cue ball needs to have twice as much momentum as it would take to move just one of the balls to its corner pocket. Or let's say the last two balls are arranged like this. Because you get to take another shot every time you put a ball in a pocket, I'm thinking a shot ahead. From this position, I can sink the 6 ball in the corner pocket, but I want to be able to finish the game by sinking the 8 ball in that side pocket right after. So I'll depend on all the momentum of my cue ball being transferred into the 6 ball so that the cue ball stops at impact to give me a straight shot to end the game. Angular momentum is the momentum spinning things have, and it's also a conserved quantity, which means angular momentum will keep something spinning in the same plane unless there's another force working against it. That's why it's much easier to balance on a bike when the wheels are spinning. It requires much more force to change the angular momentum from the vertical plane to a horizontal plane. Here's an equation for angular momentum. Angular momentum equals mass times speed times radius. The greater a spinning object's speed, or mass or radius, the more angular momentum it has. This equation has some other fun implications. Once you've got an object spinning, if you start playing with one variable on the left side of the equation, another variable on that same side will have to change so that angular momentum can stay conserved. So when I pull my mass closer to the center of this pole, my speed increases. But as I let it go further, my speed decreases. My mass didn't change, and my angular momentum can't change without some external force acting on it. So if my radius decreases, my speed has to increase to balance the equation. If I want to slow back down, I just need to move my mass further from the center. This principle comes in handy, especially for divers. Once they start a flip, they use the conservation of angular momentum to increase the speed of their spin by pulling all of their mass towards their center. Then they can stop that spin by spreading their mass out and slice into the water nice and clean. That's it for this episode. Now be sure to check out the links in the description below, and for more science and research opportunities for BYU undergrads, visit science.byu.edu.